Let's see one more sum. What is this sum trying to say? Again, too good. Within this particular sum, I shall give you one more. Within this, I shall give you one more. In figure, quadrilateral ABCD is a parallelogram. Okay, fine. It circumscribes the circle with center T. Okay, center T is what I have not mentioned, but I doubt I'll be making any use of it. Center T. Point EFGH are touching points. So you can say AB, BC, CD and DA are tangents at point EFGH respectively. They are tangents at point. If AE is 4.5, find EB. AE is 4.5, EB is 5.5, AE 4.5, EB 5.5. Find AD. Find AD. Let's start. Any idea if I have to ask you that which theorem will be applied over here? Which property is going to get applied over here? Length of tangent segments drawn from the external point are congruent. Rightly said. Rightly said. Prior to that, my solution will have these statements first. Solution. What is AE? AE is 4.5. How much is EB? EB is 5.5. These are given to me. I shall write down given. I shall write down given. What next? What is AB then? Can I say AB is equals to AE plus EB? Can I say this much? What is the reason? The reason is collinearity. A dash, E dash, B. A dash, E dash, B. Those who are asking me and those who have come across for this particular word collinearity, I shall tell you, whenever we go for any kind of addition or subtraction in a straight line, whenever we go for any kind of addition or subtraction in a straight line, we write down this as a reason, collinearity. 3 points lying in the same line. Right? So, what is AB? Then, AB turns out to be 4.5 plus 5.5. AB turns out to be 10. Equation number 2. Right, children? Quite simple. With this, now are some slightly changes. Now, what we need to do? We need to find out AD. Oh, okay. This is what AD is. Can I say now what? Is AE congruent to AH? Have you heard something called as length of tangent segments drawn from the external point are congruent? So, A is an external point. From that external point, there are two tangents being drawn, AE and AH. So, can I say AE is equals to AH? There are many who have started working also said this, since this is 4.5, this is 4.5. We are not going to do that, mind you. But yes, certainly AE is equals to AH. Don't you think so? On the same lines, B is equals to BF. So with all the 4 external points, can I apply the length of tangent segment concept? Let's apply. Now it is AE equal to AH. Equation number 3. Then BE equal to BF. Equation number 4. Thereafter, I go with DG is equals to DG is equals to DH. Equation number 5. And then I say CG is equals to CF. Equation number 6. So with A external point, with B external point, with D external point and with C external point. Right, children? Common, mind you, common reason is length of tangent segments drawn from external point are congruent. Right? Thereafter, what am I going to say? If I add 3, 4, 5 and 6, will I get something? So let's add 3, 4, 5 and 6. Adding equations 3, 4, 5 and 6. But before that, I would like to ask you one simple question. Before that, a very simple question, children. What you are going to answer is, I have written A is equals to AH. Fine. Here B is equals to BF. Is there any mistake if I write down BF is equals to BE? BF coming here, BE going there. Is there anything wrong if I write down DH is equals to DG? DH coming here, DG going there. Right? According to me, 9 on 10 students will say, no sir, there is no problem. Why? Because you are applying the same property, length of tangent segments. So why? Why you have a problem? AB is equals to BA. So I can write down BA is equals to AB. There is no issues. You are perfectly correct fundamentally, conceptually. But in context to this sum, swapping the values will not give me my answer. And this is what I want to highlight. So you have to be very careful in writing this 1, 2, 3, 4. Had I written down BF is equals to BE, or for that matter DH is equal to DG, I will not get it very easily, and I'll prove it right now. I shall prove it right now. But let me first say adding 3, 4, 5, 6. When I add 3, 4, 5, 6, what will I have? AE plus BE. So I shall write down from here AE plus BE plus CG. I'm just rearranging the term, plus DG is equals to AH plus rearranging the term. So AH, DH, BF, CF. Right? What is AE plus BE? What is AE plus BE? AE plus BE is nothing but AB. So when I add these two, it is AB. What is CG plus DG? It is going to give me DC. What is AH plus HD? It is nothing but AD. And what is BF plus FC? It is nothing but BC. Here I want to point you out. Had I taken BF here, BE there, then AE plus BF will give me any kind of addition? AE plus BF? No. Had I taken this DH here, DG here, then CG plus DH, if I were to take DH here, then is CG plus DH going to give me anything? CG plus DH is going to give me anything? No. Understand. This is a very special kind of sum where if you don't follow the order, you will not get it. So sir, are we supposed to ratify the answer? Answer is straightforward, no. Then what are we going to pick up? You are supposed to pick up opposite sides. What are we supposed to pick up? Opposite sides which form collinearity. So what did I do so? AE with AH. But I had to complete AB. That's the reason I went for BE, then BF. Why? Because along with AE, if BE gets added, then and then only I'll get AB. Thereafter, I picked up the opposite side. You could have started with C also. I started with D. You could have started with C also. Then DG with DH. But I need to complete this opposite side. Therefore, the partner for DG is GC or CG. Keep this in mind, children. Keep this in mind. So AB plus DC is AD plus BC. Now what, sir? Now I shall say quadrilateral ABCD is a parallelogram. I did not write down one condition. That is what I'll write down. So let this be equation number 7. Whatever I'm going to write down now could have been written first also. Whatever I'm going to write down as equation number 8 could have written down in equation 7 also. So now after writing this as equation 7, what I'm going to say, since quadrilateral ABCD is a parallelogram, is it given to us? Indeed, yes. What is the property of parallelogram? Opposite sides are equal. So can I say AB is equals to CD? Can I say AD is equals to BC? Let this be equation number 8. What is the reason? Opposite sides of parallelogram, so it's parallelogram are equal. With 7 and 8 equations from equation 7 and equation 8. So 7 and 8. AB plus DC, but AB is already equal to DC. So can I say here AB plus DC? Instead of that, can I say AB plus DC? But DC is equal to AB. So can I say AB plus AB? Likewise, AD plus BC. So can I say AD? BC are congruent. So AD plus AD. 2 times AB is 2 times AD. 2 gets cancels off. What I'm left with? AB is equals to AD. What I'm left with? AB is equals to AD. Already I have the value of AB. I wanted the value of AD. So this is nothing but equation number 9. Now from equation 2 and 9, what is the value of AB? 10. That's what the value of AD is. AD is also 10. This question gets completed. In the starting of the sum, when I was doing the sum or when I initialized the sum, I did said that I'm going to give you one more question in this. So let me highlight with a different marker. What added question can be given? What added question can be given with no data? I'll tell you what the question will be. They will not give you any data as such. AES 4.5, EBS 5.5, they will not give you, mind you. Then what they shall give you? They shall give you a quadrilateral ABCD is a parallelogram. It circumscribes a circle with center T. Even center is not required. Even center T, you can see I have not utilized anywhere. So even center T is not required. Point E, F, G, H are touching points. Prove. So I'm writing with a different marker, mind you. This is an altogether different question. This is altogether a different question. But our answer is the same. Our answer is the same. Question being different, but answer happens to be the same. What? Prove that. I'm just writing TP. Prove that quadrilateral is a rhombus. Quadrilateral ABCD is a rhombus. Quadrilateral ABCD is a rhombus. Now how can I prove it is a rhombus? So what will not come into the picture? Let me tell you that also. This won't come into the picture. Our sum shall start from here. Our sum shall get end over here. Why, sir? How can a parallelogram get converted into a rhombus? What makes a parallelogram get converted into a rhombus? Answer is, if in a parallelogram any one pair of adjacent side happens to be equal, the parallelogram is no longer a parallelogram, it's a rhombus. I reiterate. If in a parallelogram any one pair of adjacent side happens to be equal, then the parallelogram is no longer a parallelogram, it's a rhombus. What is AB and AD? AB and AD are nothing but adjacent side. So in a parallelogram, if the adjacent sides are equal, the quadrilateral is a rhombus. Same question, and we have a different two proof. Answer remains the same. Did you get, my children?